Ooh. All right. Number one, determine if it's a polynomial function. Determine the degree. So f of x equals 3x to the sixth plus 8x to the fourth. This is a polynomial function. This is a polynomial. Meets the polynomial, the characteristics of a polynomial. Okay. So it is a polynomial. The degree of the polynomial is 6. It's just the highest exponent. Okay. Yes. Is this a polynomial? Well, the problem here is that divided by x, okay, we have to have positive exponents. This right here is the problem. This is not going to be a polynomial. This 5 divided by x is a problem. So this is not going to be a polynomial. Let me write it down. So all right. Let's go to the next one. Sorry, let's put my answer here. 3 is the right a polynomial function. Well, we notice it's continuous and there's no asymptotes, no gaps, no holes. So this should be good. So 3 is yes. Just a moment. All right, the next one, is this one continuous? Is there any gaps on this one? You see how there's a gap here? Like that's bad. It's got to be continuous to where if I should never be able to pick up my cursor and like be able to get to the next part. So this one's going to be no. So no on that one. All right, question 5. Have these functions, and what we need to do is tell the end behavior. This is what we call an even negative. So the first one's an even negative. So an even negative, it's going to falls left, and it's going to fall right. So that first one for me is an even negative. So I'm going to look for the one that falls left and falls right. I'm going to go ahead and do this first, and I'll come back to that. The next one's this is an odd positive. Odd because its highest exponent is 3. Positive because it's got a positive leading coefficient. So this falls left, rises right. Okay. This one's an even, and it's positive. So this one rises left and rises right. You could look at your notes here. I'm just copying this down. This is an odd negative. And this one rises right, or rises left, I'm sorry. Rises left and falls right. Okay. So now the first one needs to fall left and fall right. So it needs to be going down in both ways. That's this one. It's going down the left and down the right. This next one falls left. It's going down the left, but up on the right. So down the left, up on the right. So that's right there. This next one is going up, left and right. So it's right there. It rises left and rises right. And the last one, it rises left and falls right. Okay. So question 6, we're going to use the leading coefficient test to determine the end behavior here. 8x to the 7th minus 6x to the 6th plus 8x to the fourth plus 5. So we're going to look at the degree here. This is a odd degree, 7, and it's a leading coefficient's 8, so it's positive. Positive leading coefficient, which is 8. So odd positive, you could look in your notes, odd positive, I also talked about it back here. Odd positives go down on the left and up on the right. So it falls left and rises right. Okay. All right. This one is an odd. Looks like we got an odd positive again. So 5. You got an even negative? Okay. Well, glad I could change it up a little bit. Odd positive, we just did that. So it falls left and rises right. Now you could check your notes to get this. And we kind of talked about there's 4 categories it falls into: odd positive, odd negative. Oh, wait, I'm going to write down their sentence here. Falls to the left and rises to the right. I'm sorry, I was going to write out the sentence. The graph of f of x falls to the left and rises to the right. Let's do 8. There we go. Looks like we got a negative 8x to the fourth plus 5x squared minus 3x plus 7. This one's an even, so even degree. And then negative. What does an even negative do? Even negative. So it's an even degree and then it's negative. So it's going to fall left and fall right. Even negatives fall left. Evens go in the same direction. Negative means they both fall. So the graph of fx falls to the left. Find the zeros of the polynomial function, the multiplicity of each zero. State whether the graph crosses or touches at each zero. So I get f of x equals 7 times x plus 1, x minus 1 squared. It's in factored form. So in factored form, you could solve each thing, but x plus 1 equals 0. X equals negative 1, add 1, x equals 1. Now, this one happens once. So this is a multiplicity of 1. And since it's an odd multiplicity, it's going to cross it. It crosses the x-axis. This one's a squared, so it has a multiplicity of 2. So this one turns around. What do they say? Touches and turns around. Is that what they... Touches and turns around. So the zeros are negative 1, 1. There are 2 zeros. The multiplicity of the smallest 0. The smallest 0 is negative 1, has a multiplicity of 1. And the multiplicity of largest 0 is 2. Now, you agree? Mm-hmm. All right. I skipped ahead there. Across the x-axis, x equals -1. So it crosses there and it touches it at 1. I wrote that backwards on my paper there, so I apologize. 10. These are not hard to do. It's just a lot to write down. F of x equals 7 times x minus 4 times x plus 9 to the third. So you're going to set each one equal to 0. Add 4, subtract 9, x equals -9. This one is a multiplicity of 1. This one has a multiplicity of 3 because it's got a cube. And so on both of these, it's going to cross the x-axis. And the reason why it's because it's an odd multiplicities. It's going to cross the x-axis in both. So the zeros are 4 and -9. You could probably do this in your head. There are 2 zeros. The multiplicity of the smallest 0, largest 0, is 1. Multiplicity of the smallest 0 is 3. Okay. Determine the behavior at each 0. So it's going to cross the x-axis at both because it's odd. Okay. Find the zeros and get the multiplicity of each 0 and then state whether, okay. So on this one, I'm going to factor this. On this one, the first thing I need to do is factor. I'm going to solve it, so I'm going to make it equal 0. So I'm going to factor out x. I need two numbers that multiply to 196 and add to that. What about 14? -14, -14. That's -14, -14. So I set each of these equal to 0. So x equal to 0. This one's 14 equals 0. And then you solve them. That's already solved. Add 14, x equals 14. So 14 happens twice. So 14 has a multiplicity of 2. And then you got 0 with the multiplicity of 1. So the zeros are 0 and 14. Okay, determine the multiplicities of each 0. So there are 2 zeros. The multiplicity of the smallest 0 is 1. And the largest 0 is 2. Okay. So what's the end behavior? So what's going to happen is one of them it's going to cross. It's going to cross in the multiplicity of 1. So the graph crosses at multiplicity of 1, which is 0. Axis at x equals 0. And it touches the x-axis and turns around at 14. All right.
What do you have?
All right. Find the zeros of the polynomial function. Get the multiplicity of each 0. So I could write down the function x cubed plus 6x squared minus 9x minus 54. Okay, so I can do, it's 4 terms, so I got to make it equal 0. I could do factoring by grouping, so I could put parentheses on the first two, parentheses on the last two, and see what do these two have in common. These two have x squared, so I'm going to take out x squared. I'm left with x plus 6. These have negative 9 in common. Negative 9 divided by negative 9 is x. Negative 54 divided by negative 9 is be 6. All right. So these have x plus 6 in common. So I'm going to factor out x plus 6. I'm left with x squared minus 9. Next thing I'm going to do, I'm going to factor that further because x squared minus 9 can factor further. X plus 3, x minus 3. So there's your factored form. Now I'm going to solve it. So x plus 6 equals 0. X plus 3 equals 0. X minus 3 equals 0. Subtract 6, x equals negative 6. Subtract 3, x equals negative 3. Add 3, x equals 3. Okay, so I have 3 zeros. The zeros are negative 6, negative 3, and 3. So negative 6, negative 3, and 3. Okay. Determine the multiplicities. Well, each one there's 3 zeros, and the multiplicity of each one is 1. So determine the behavior of the function in each zero. Well, since they all have a multiplicity of 1, the graph's going to cross the x-axis at all zeros. All right. Use the intermediate value theorem to determine if there's a real zero between 1 and 2. So f of x equals, this is number 13, 4x cubed minus 4x minus 3 between 1 and 2. So f of 1 is 4 times 1 cubed minus 4 times 1 minus 3. F of 2 is 4 times 2 cubed minus 4 times 2 minus 3. So we'll figure this out. So 4 times 1 cubed minus 4 times 1 minus 3 is negative 3. And so we'll do it for 2. That's 21. So it's because f of 1 is less than 0, negative 3. F of 1 is equal to negative 3, which is less than 0. And actually, f of 2 is greater than 0. Let's go to the next question. Answers part A through E using the graph below. So let's look at 14. We've got f of x equals x cubed minus 4x squared minus x plus 4. So we're going to analyze this. This is an odd positive because you got an odd degree positive. So odd positives, what they do is they fall to the left and rise to the right. So we're going to say that the graph falls to the left and rises to the right. Okay. What the heck? Find the x-intercepts. So the x-intercepts, we got to make it equal 0. So 0 equals x cubed minus 4x squared minus x plus 4. Okay. So the parentheses are on the first two. Differences on the last two. What do these two have in common? They have x squared. So I'll take out x squared. I'm left with x minus 4. These two have -1. So if I do that, it'll be x minus 4. So I'm going to have x minus 4, x squared minus 1. So now I'm going to have x minus 4, x minus 1, x plus 1. Okay, so you set each one equal to 0. So plus 4, x equals 4. Plus 1, x equals 1. Subtract 1, x equals -1. So my zeros are, my x-intercepts are -1, 1, and 4. So at what point x-intercepts does it cross the x-axis? Well, it's going to cross the x-axis at -1, 1, and 4. Okay. All right. At which points does it touch the axis and turn around? There's no points where it touches and turn around. All right. The x-intercept or the y-intercept, where it's just going to be the constant. Equal to the constant. Constant's 4, so the y-intercept is 0, 4. Because 4 is the constant. All right. Actually, be y equals 4. All right, determine whether it has symmetry. So on this one, I have to find f of -x, which would be -x cubed minus 4 times -x squared minus x minus 4 minus minus 4. So f of -x is equal to -x cubed minus 4x squared plus x minus 4. Negative f of x is equal to the negative of all this. So it'd be -x cubed minus 4x squared minus x plus 4. Negative f of x is equal to -x cubed plus 4x squared plus x minus 4. These two are not the same. So f of x does not equal f of -x. F of -x does not equal negative f of x, so that would have neither. Neither. Okay. Now we're going to use the graphing tool, so the maximum number of turning points. So turning points would just be points. That's going to be 3 minus 1, so it's 2. So quick enlarge the graph. So I need 4 points. So I need to have the x-intercepts are -1, 1, and 4. The y-intercept is 4. And this one should be, I'm sorry, it's a +4. My fault. There we go. So I dropped the intercepts there. Check answer. Okay. All right, so we've got f of x equals x to the 4th, 16x squared. So this is an even positive. So this one rises to the left and right. The graph of f of x rises left and rises right. Okay, find the x-intercepts. So I'm going to make this equal 0. So make x-intercepts, make f of x equals 0. So 0 equals x to the fourth minus 16x squared. So I'm going to factor out x squared. I'm left with x squared minus 16. So be x squared, x plus 4, x minus 4. So I've got x squared equal to 0, x plus 4 equal to 0, x minus 4 equal to 0. So this is just going to be 0. It's going to be negative 4. That's going to be positive 4. This one has a multiplicity of 2. 0 has a multiplicity of 2 because it's squared. These have a multiplicity of 1. Okay. So the x-intercepts. X equals negative 4, 0, 4. Negative 4, 0, 4. Huh. What zeros does it cross the x-axis? So it crosses the x-axis when it's multiplicity of 1. So it crosses the x-axis on these. So it crosses the x-axis at x equals negative 4 and 4.
At this time.
All right, when does it turn around? Well, it's got a multiplicity of 0's got a multiplicity of 2, so it touches and turns around at x equals 0. Find the y-intercept by finding f of 0. So talked about earlier, it's got even symmetry because f of x equals f of negative x. Okay, and then it's going to have the graph will have 0 at negative 4, 0 at positive 4, and then 0 here. So it's going to be rising to the left, double 0, rising to the right. So it's going to be this one. All right. So now let's look at the next one. 16, use the leading coefficient test to do its end behavior. So we've got f of x equals 10x cubed minus 25x minus x to the fifth. So I've got to rearrange this. So I'm going to rearrange this and put negative x to the fifth. I'm going to do this in standard form order. So this is a negative leading coefficient, odd, negative. So this is an odd negative. And with an odd negative, what happens is it rises to the left and falls to the right. So it rises to the left and falls to the right. All right, find the x-intercepts. So for x-intercept, make f of x equals 0. So 0 equals negative x to the fifth plus 10x cubed minus 25x. So I've got negative x coming out, x to the fourth minus 10x squared minus 25 or plus 25. So what multiplies to 25 and adds negative 10? What about 5 and 5? So it'd be x squared minus 5, x squared minus 5. Okay. So then these are going to be radicals. So this is going to be, I'm going to do negative x equals 0, x squared minus 5 equals 0. So that's just going to be 0. But this one's going to be plus or minus the square root of 5, and that's going to happen twice. Okay, because it happens with this one too. It's x squared minus 5 equals 0. 5. So your solutions are going to be 0, or negative square root of 5, 0, and then square root of 5. Negative square root of 5, 0, and then square root of 5. All right, where does it cross it? Well, 0 has a multiplicity of 1. These two have a multiplicity of 2. And so if it's a multiplicity of 1, it crosses. So the 2, it touches and turns around. Turns around. So on this one, the x-intercept where it crosses the axis is a 0. All right, the x-axis where it touches and turns around, there's 2 of them because I have a multiplicity of 2, is negative square root of 5 and square root of 5. Find the y-intercept. So the y-intercept, just make x equal 0. F of 0 is equal to negative 0 to the 5th. Oh my goodness. Plus 10 times 0 cubed. That's 25 times 0, which is 0. So f of 0 equals 0. So the y-intercept 0. So does the graph have origin symmetry, y-axis symmetry, or neither? So f of negative x equals negative times negative x to the 5th plus 10 times negative x to the 3rd. That's 25 times negative x. So negative x to the 5th, that's going to make that negative. It's going to make that positive. It's going to be minus 10x to the 3rd plus 25x. So f of negative x is that. Negative f of x is going to be the negative of this, x to the 5th, negative x to the 5th plus 10x to the 3rd minus 25x. So you negate all that, it'd be x to the 5th plus 10x to the 3rd plus 25x. And so in this case, f of negative x equals negative f of x. And so this is going to have origin symmetry. So it's going to have origin symmetry. So the graph of f. It's the graph. It touches at 0. It's got origin symmetry. It's got double roots at the square root of negative 5 and positive 5. And it rises to the left and falls to the right. So it's going to be this one. Oh my gosh. All right. Let's look at 17. Use the graph. So f of x equals 6x squared plus x to the 3rd. So this one is an odd and positive. So odd and positive, this is going to fall to the left and rise to the right. So it falls to the left and rises to the right. Oops, sorry about that. Falls to the left and rises right. I apologize about that. Didn't read that well. All right. The x-intercepts. So the x-intercepts are when f of x equals 0 when it crosses the x-axis. So we're going to set this equal to 0. 6x squared plus x cubed. And I'm going to rewrite this. Okay, I'm going to factor out x squared. So I've got x plus 6. Could you shut that door too? Sorry. All right, so then you set each part equal to 0. This one's going to have a multiplicity of 2 here. This is going to be 0. This is going to have a multiplicity of 2. And then you subtract 6, x equals negative 6. That's going to be a multiplicity of 1 because it happens once. Okay, so my x-intercepts, x equals 0, comma, negative 6. All right, what happens? So at negative 6 is a multiplicity of 1. So since it has a multiplicity of 1, it's going to cross it at negative 6. All right, and then next one, it touches and turns around at 0 because there's a multiplicity of 2. The graph. So this one does it at 0 because 0 is a multiplicity of 2. Make x equals 0. So f of 0 is 6 times 0 squared plus 0 cubed. That just be 0. So f of 0 is 0. So the y-intercept is 0. So y-intercept. So it's y equals 0. All right, determine the symmetry. So the symmetry, I'm going to find f of negative x. So that's going to be 6 times negative x squared plus negative x cubed. So f of negative x is equal to, this is going to be positive, minus x cubed. Okay. Negative f of x is going to be negative times 6x squared plus x cubed. So it'd be negative 6x squared minus x cubed. And so these are not equal. So f of x does not equal f of negative x, and f of negative x does not equal negative f of x, so there's neither. So that says neither. Okay. Now the graphing tool, so what I'm going to do is I'm going to click to enlarge the graph. I'm going to use the polynomials. I'm going to plot the x-intercepts. My x-intercepts are 0 and negative. Whoops, I didn't mean to put that. Let me put this as 0. Let me redo that. Clear. So it's going to be at 0 and negative 6. And then we've got a double root at 0. Okay. So since one of my zeros is also the y-intercept, I'm going to have to find an additional point. So I'm going to find an additional point. I could use my calculator. 6x squared plus x to the third. Let's say I did 1. So I did 1. So f of 1 equals 6 times 1 squared plus 1 cubed. Someday. All right, so this would give you 6 plus 1, which is 7. So 1/7's a point on there. So I'm going to need another point. So let's do 1/7. Whoops. I didn't mean to plot that point. Let's clear that. So 0, -6. Clear that. Sorry, I keep on messing up. 0, -6. I don't know how well it's going to read this. 0, 0, and 1/7. I'm going to need another point too. It's going to sit like that. So I'm going to need another point here. So let's see what -4 does. -4 is at 32. So I could look here. -4 is at 32. So I'm going to do -4, 32. Okay. And so hopefully that gives me what I need. Oops, they didn't like that. So let's fix this. I don't think they like the 1/7. Let's do 232. Okay. Having issues with the graph working. So I've got one at 0, -6, 0, 0, 232. So let's see if I can scroll down here. I'm going to go to edit coordinates. I just found this feature, so that's good. I need that one. Oh, this is in the wrong spot. It's at 0, 0. So you might need to edit the coordinate. Let's make sure the other ones are in the right spot. This one should be at 232. See, that's not in the right spot either. So 232. And then this one, that one is at -432. All right. Okay. Let's look. All right. All right. For the polynomial function, f of x equals x squared times x minus 3 cubed times x plus 4. We're going to determine let's look at the degree. So the degree is going to be 2 plus 3 plus 1. So it's going to be 6, which is even. The leading coefficient is going to be 1 times 1 times 1, which is 1. So it's going to be positive. So an even positive. So if it's even positive, it's going to rise to the left and to the right. All right, find the x-intercept. So it's already in factored form. So you're just going to do x squared equals 0. It'll be x, and then you're going to do x minus 3 equals 0, and x plus 4 equals 0. Okay, I'm going to ignore the squared there. So it's x equals 0. Add 3, x equals 3. Subtract 4, x equals -4. So my x-intercepts are going to be -4, 3, and 0. So the x-intercepts are -4, 0, and 3. All right, so now on this one, we're going to look back here. 0 has a multiplicity of 2. That's even. So when it's even, it's going to turn around, touch and turn around. All right. When on for 3, the multiplicity is 3. And this one's odd, so it's going to cross the x-axis. And then for -4, it's a multiplicity of 1, so it's odd. It's going to cross the x-axis. Okay, so 2, so the graph crosses the x-axis at the zeros of -4 and 3. 4, 3. And it touches the x-axis at 0. All right. Find the y-intercept. So the y-intercept, you're going to do f of 0. Just plug in 0 for x. So f of 0 is going to be 0 squared times 0 minus 3 cubed times 0 plus 4. So 0 squared 0 times, that'd be -27 times 4, which is 0. So f of 0 is equal to 0. So the y-intercept 0. Y-intercept is 0. All right, determine the symmetry the graph has. So I'm going to do the f of -x, which would be -x squared, -x minus 3 cubed, and then -x plus 4. Okay, and so this is going to be x squared. This is going to be -x plus 3 cubed, and then -x times -x minus 4. Okay. Negative f of x is going to be -x squared, -x squared times x plus 3 cubed times x plus minus 4. And this one's close to being true, but the problem is it's going to make that negative. Cubed times -x minus 4. And so f of x does not equal f of -x. And f of -x does not equal negative f of x, so it's going to be neither. Now, when it comes to graphing, we know that the x-intercepts are at -4, 0, and 3. We know that it rises to the left and to the right, so we know it's going to be rising on both ends. Okay, so let's look at the graphs here. These two rise on both ends. I need to zoom in and see what's going on here. And then there's a triple root at 3 and a double root at 0. So let's see if we can zoom in and see here. And zoom in on this one. So there's a triple root at 3. There's a single root at 4, -4. And it goes down low, and then it goes to this one. There's a double root here, and then there's a triple root here. So it'd be that one. Some of it. The graph on the right is a complete graph that's continuous and displays all the end behavior, all the zeros and integers. Answer the following question. List the zeros whose multiplicity is even. All right, we're going to list the zeros whose multiplicity is even. Well, here's the thing. They're none, because they all cross the x-axis. There's none. So there are no such zeros. So multiplicity, even, there are no such zeros. Now, multiplicity odd, that would be your -3, 3, and 5. So multiplicity odd, that would be -3, 3, and 5. Okay, write an equation as a product of factors of the polynomial the graph might represent. Use the leading coefficient of 1 or -1 and make the degree as small as possible. So what you're going to do is you're going to plot the zeros. So for the zeros, first off, it's going down on the left and rising to the right. So it's going to be a positive leading coefficient. And so for x minus 3, you're going to do x plus 3. For positive 3, you're going to do x minus 3. And for 5, you're going to do x minus 5. So let's see if this works. So x plus 3, x minus 3, x minus 5. X plus 3, x minus 3, x minus 5. All right, so use the equation to find the y-intercept. So to find the y-intercept, I'm going to do f of 0, 0 plus 3, 0 minus 3, 0 minus 5, just 3 times -3 times -5. So this would be 45. Just the y-intercept. It's 45. All right. On to question 20. So on this graph here, we have this, when it settles it like that, that's a triple root. So that's going to have an odd multiplicity. The y-intercept looks like -4. We've got a single root there of 1, and then a double root of 2, which has got a multiplicity of 2. So which one's got a multiplicity that's even? Well, the root has a multiplicity that's even is 2, because this one has a multiplicity of 2. Okay. Let's do zeros where the multiplicity is odd. So the multiplicity is odd for -1 here, because that's got a multiplicity of 3, and for 1. So write it as small as possible, the factored form. So this first one, the root's -1. That means the factor that's tied to that is x plus 1. That's got a third power times x, if it's 1 is the solution, it's x minus 1. That's just a single root. Times, and then the next one, which is x minus 2, and that's to the second power, because it's a double root. Okay. The y-intercept, so to find the y-intercept, let's make x equal 0. So the y-intercept is f of 0. So f of 0 is equal to 0 plus 1 cubed times 0 minus 1, 0 minus 2 squared. 0 plus 1's cubed, 1 cubed, which is 1, times -1. -2 squared would be 4. 1 times -1 is -1 times 4 is -4. It would be 0, -4. So the y-intercept is -4. Okay. 21. Experts fear that without conservation efforts, an endangered species could disappear from the wild by 2022. Just 100 years ago, there was at least 100,000 of these endangered species. By 2010, the estimated world population of endangered species was 11,700. The bar graph shows the estimated world population of this endangered species for 1970 to 2010. Also, it's a polynomial function with its graph that models the data. Use the information. Find and interpret f of 40. So f of 40 is going to be 0.77 times 40 cubed plus 25 times 40 squared. 884 times 40 plus 37,800. Okay. So I'll type this in my calculator. 0.77 times 40 cubed minus 25 times 40 squared minus 884 times 40 plus 37,800. It's 11,720. So the interpretation in the year, now 40 is year since 1970, so 40 would be in the year 2010, because it's believed this is years since 1970. Let me double check. Years after 1970. So we add 40 to that. 1970 would be year 2010. Population of the species would be 11,720. All right, so type this as a point on the graph. So on the point on the graph, this would be 40, 11,720. So it'd be 40 be your x, 11,720 be your y. Do I use commas? Okay. Now we need to see if it over or underestimates the graph shown. So what we have to do is look at the bar graph. The bar graph shows that it's 11,700. So that's the actual. That's the actual. So we're going to do the actual, and this is the predicted. The original is the predicted. So we're going to do 11,000. So we're going to do actual minus predicted. So we're going to do actual 11,700 minus the predicted 11,720. It's going to be negative 20. So the model underestimates it by 20. So the model underestimates it by size of 20 when compared to the bar graph. I made a mistake here. The model said 11,720, and that's larger than the actual by 20. So the model, it overestimates it. The model overestimates because the model is greater than the actual. So the model overestimates it by 20. All right, leading coefficient test, we'll go back to the original model. So the model is an odd, so it's an odd positive. So it's an odd positive. So if it's an odd positive, falls to the left and rises to the right. So what's going to happen? It's going to rise to the right, and it's not going to be useful because as it's rising, the endangered species should be getting smaller, so it's not going to be useful.